Alright, Harmony Science Academy, we're looking at rational exponents. Okay, we're going to actually build on what we've already studied. So it's going to be worth our time to look at the warm-up for today and make some connections. Okay, so for example, you guys know that the cube root of 27 equals 3. Okay, if you don't know, here's what you do know, is that 3 times 3 times 3 equals 27. Okay, this also equals what? There's 3 of them, so it's 3 cubed. A cube root will cancel a cube. So if I cancel this, I'm left with just a 3, which is right outside the radical. You see that? So let's do one more. So if you have n to the 7th, the opposite would be a 7th root. To cancel that, so you'd be left with n. Okay? Now I'm saying that because when we circle, for example, in this case, 3, right, because of the index, that means that out of here would pop out what? A 3 on the outside, right, because of this index. So hopefully you see the connection with this whole circling process, and more importantly, your knowledge that an exponent can be canceled with the radical of a matching index. Okay. All right. If that helped, good. If not, let's just march forward the way we did yesterday. Okay. So here we have for 31 a negative on the outside. Never go and put something on the outside in. We're looking to take something from the inside out if it qualifies. Okay. So we have 1, 2, 3. We have, and you guys can check that. Okay. Of course, if you can't go this fast, that's fine. Go through the factor tree. Okay. Anyways, this index of 3 tells me to circle a factor that repeats 3 times. I found it. Now, this technically, if you were following with that little bit of a lesson I just gave right now, would be this. Okay. The negative cubed times a 2 times a 3 3 times, right? Or 3 cubed times x. So this cube root is going to cancel this cube and this cube. Okay? So I would end up getting a negative on the outside, negative times a negative out here. Because this cube root cancels this cube root, only the negative pops out. This cube root cancels this cube, so the 3 pops out. And these guys would be left on the inside. Negative times a negative is positive, and I've got the finished result. Okay? Alright, now let's look at this one also a little fast here. So we have the negative 6. And this would be what? 12 times 12, right? So we're going to have 2. I'm trying to do this in my head to save us some time here. So 12 times 12, so that's 2 times 2 times 2 times 2. So that's 4 and 4, and then 3 and 3. And you guys can go a little slower and check that I'm correct. Alright. So in this case, because of this index, we're going to circle every 2. Alright. And again, if we make the connection between this understanding, we'd have negative 6 square root of what? 2 squared. This is 2 squared times another 2 squared times 3 squared times x squared times x. Okay. So again, the whole point is that I'm emphasizing here is Or is this just a game that we made up? No. You guys understand that a square root, in this case, right, will cancel a square. So if this disappears and this disappears, only the 2's left over. So here's this 2 from there, the 3, and the x. Okay? Or this cancels him, this 2, this cancels this square, this 2, this cancels this one, the 3, this cancels that, the x. Okay, so we can also even scratch those off, and we're left with just the x. Okay, so we can clean it up here, and that's going to be 24 negative 72x times square root of x. Okay, so anyways, now it's recorded. You guys can watch that over and see if that helps. Okay, anyways, let's jump into rational exponents. There's going to be easy, medium, and hard problems that we're going to practice. The CBA will not have hard ones, just easy to medium. So don't stress out too much. Try and tackle all of them. Okay. This here, after reading the definition, let's keep it simple. All this means is, for example, if I have 4 to the 1/3, okay, I have basically a base, right? An exponent that's a rational, a fraction. What does that mean? What do these notes mean? It means that this numerator value will go right there. Okay? 4 to the 1, like always. The exponent 1. But since it's a fraction, this fraction, the denominator part, tells you that we have a radical with index 3. Okay? So let's try another one. And by the way, this and this are saying the same thing. Okay? So let's try 7n squared. Okay? That, let's put it to the 2/5. I wrote the fraction like that. Let's just keep it like this, all of us, okay? All right, so again, we have 7n squared, okay? That's the base. This is being squared, okay? So the m right there. And this, the fact it's a rational exponent, a fraction, immediately tells me that this bottom part is going to give us a radical with a 5 index in this case. Okay? So it's really that simple. Now we're going to apply it to problems that are easy, medium, and hard. And we'll probably we'll be reviewing it enough days so you can get some additional practice and get faster and stronger. Okay? So here we have these two problems. Let's go ahead and tackle them real quick. Okay, now the tips that you want to take a note of is you want to turn the rational exponent into radical form. So use the definition that we just looked at a second ago. Then once you have it, you want to factor the radicand, which you guys know how to do. Okay, as long as the numbers aren't too big, and then simplify. So let's go ahead and do that. So I have 64 m to the 4th. That to the 1st power. Okay, that's the easy part, right? Now, because it's a rational exponent of fraction, I know the bottom is going to create a radical with an index, in this case, of 2. Okay, so let me squeeze in a very valuable step here. So what this means is we have 64 to the 1 and m to the 1. Okay, this is going to be very important. You'll see why in a little bit. So take time to copy it and start thinking about why, what this means. Okay. All right. So I'm going to save us time from doing the factor tree on the side. You guys can do it on the side. But in here, I know it's 2 times 2 is 4. 8. Let's see here. 16, 32, 64. Okay, one time. And M. Okay. All right. So I've turned, look at what I've done. The first thing is I turned in this rational exponent into a radical form. Now I do what I've been doing, okay? I just look to see, is this problem going to be easy, medium, or hard? Okay, but no matter what, you give them a try. So the index is 2, so I'm going to circle here, 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 there, and there. Okay, looks like everybody's repeating twice. Nobody is going to be left in the radical, so we won't need it. So we have 2, 2, 2, and nothing's left inside, so I have 8m. Okay? Alright, so that's that problem. Okay? Let's go ahead and focus now on this one. There's a little more going on here. So let's go ahead and get the party started. So the first thing to do is turn the rational exponent to radical form. Okay? So I have 25r squared. This negative, right? Remember, anything divided by 1 is itself. But this negative tells you to flip it. Okay? So I've already applied. As soon as you see a negative, that's what you do. It looks a little scary. All you have to do is work with this the way you always work with them. And don't forget to write it in this fraction form. Okay? So this is now just 3 halves. 3 halves. Okay? So I'm going to go ahead and do what I do down here. Don't let the whole fraction intimidate you. Okay? All right. So I have half. And I've got this guy. 25r squared. Okay. Remember, the 3 is the exponent, right? It's in the numerator. The denominator is what tells you what? We have a radical with this as the index. Okay. All right. So notice this one fraction. Yes, it's scary, but it's not doing anything. It's just right there, okay? So here it is again, right? There it is. Now let's focus on the bottom. Now, remember how I distributed this exponent? That's going to be even more important in this case, so pay attention here, okay? So we're going to have 25 with the 3. We're going to have the r squared also with the 3 exponent, okay? This is going to allow you to save some time and do them all the same way, so it's a win-win, okay? Now, before you get all messy, factor this guy, right? This one should be easy. It's 5 times 5. So we have 5 times 5. If you do the factor tree, and this is r times r. Okay? All right. So this would be considered kind of like a medium level type problem. Oops, and I forgot that fraction. Okay. All right. So, what are we going to do now? This says that this repeats 3 times. This repeats 3 times, so let's go ahead and do that. Okay, there's that annoying little part there. So now I have 5 times 5, but I need it 3 times. So times 5 times 5 times 5 times 5. And then same thing with the r times r. I'm going to have r times r times r times r times r times r. Okay? So this index now is telling me to circle all the pairs. So I've got 1, 2, 3. These repeat twice, these repeat twice, and these repeat twice. So Okay, just put that little annoying thing. So here we're going to have the 5 pop out, the 5 pop out, also from here, R, and R from there, and an R from there. Alright, so let's go ahead and go through the last step here. And we've got this, 5 times 5, 25, 125, and R cubed. Okay. Let's find out what is going on your minds in class. Thanks for your time, guys.